So we are very excited to start the day off. We have an amazing opening keynote speaker that I'm very excited about. Jory Burson, I've learned a ton from her. You can learn a lot about JavaScript, about Node, about standardization, which you're going to learn about right now. But I'm going to let her tell you a little bit more about herself. And remember to tweet out for the conference and enjoy the talk from Jory.
Good morning. It's a real pleasure to be here with you all this morning. I am a nerd for standards, and I hope that you all are as well. So yesterday we heard some pretty cool talks about IoT, about machine learning, about serverless architectures, offline applications, and so many other contexts. But front and center to all of those talks was our good friend JavaScript. So how is it that one language can be powerful enough to support all of those different contexts and meet all of the requirements of different use cases and still be a practical choice at the end of the day? Well, oh, that finally started going. That's cool. There are a lot of reasons, for sure, but one of the more interesting, I think, and dare I say important, is that JavaScript is an openly standardized programming language. So I'm going to take a stab at framing what that means for you in a way that hopefully helps you understand JavaScript a little bit better, but also I also hope it gets you excited about getting involved in JavaScript and other standards projects and in open source. Cyril made this joke the other day, actually, at his talk, and I thought, oh, that's great. So standards are having a little bit of a moment in our community as well. I think there's a lot of interest in how JavaScript gets made, how the sausage gets made. And I think that's in part because the process is a little bit opaque, like how does that happen? And they directly and indirectly affect our work as web developers. So I think it's probably a really good idea for you all to have a sense of what's going on. And hopefully this talk is going to be a great place to get started. So why is this important? A lot of developers are learning JavaScript as their first language. And as they're deepening their skills and their experience, they're also getting a broader awareness of the landscape from open source projects to open web standards. Now, open source and open standards are essentially two philosophical approaches to similar problems, which of course is, will this cat ever roll over? We don't know. How do we display our cat art on the internet in a more effective way? So anyway, over the coming years, we're going to see a lot more transference of ideas from how we create software in an open source fashion to the standards world. And a lot of things are changing in the standards world. So there's a lot to share and learn across these different approaches. So hopefully by learning a little bit more and applying your own individual experience in open source, you can help shape the future of community-driven web development, regardless of the context that you're developing for. So my name's Jory. I serve as the standards liaison for Boku, and I advocate on behalf of developers at organizations such as the JS Foundation, Ecma International, the W3C, and MDN's Product Advisory Board. So in those groups, I'm a member of the JS Foundation TAC. I participate at TC39, as well as a new technical committee called TC53 that I'm really excited about in the IoT space. And I serve on the executive committee of ECMA International and the W3C Advisory Council. And I totally, the first time I met Tim Berners-Lee, took a selfie with him, and I do not regret that at all. So how did that happen? How did I get there? What mistake did I make, essentially? What happened is I started working at Boku, and I started meeting all of these amazing people who are web developers. And I was doing education and community work at Boku. At the time, our office was just down the street on Congress Street here in South Boston. And a lot of my coworkers were involved in groups like the TAG, or we're just getting started in TC39, having come from jQuery. And I was helping kind of coordinate and do a lot of like community work around that. And I just started getting really curious, like how is it that, you know, we are, like this group of people can get in a room and make a decision that affects all these other people. I was in my 20s, so I was like, when is there going to be an adult that comes around and says like, no, you can't do it this way? Like I was looking for that. So it just seemed crazy that, that folks could be, that just everyday folks that I really enjoyed working with could be setting the direction for the web. And they're amazing people, and I've learned so much from all of these folks, and even more folks that I couldn't fit on the screen. So that was sort of like my first hook into it. The other thing I started doing was reading and researching a lot, because now that my interest had been piqued in the process, it was probably a good time to kind of get a picture of how this problem fit in the greater scope of standards research. So these are a few of my favorite books about standards. And if you want to chase some turtles all the way down, then I highly recommend checking them out. Also, specgraph.org, which is maintained by a guy named Toby Langle, is a great resource as well. So with my new knowledge of the folks and the research and so on and so forth, I started trying to map this whole thing together, because it was still really complex to me. That's what I learned, and not any one person really knows what everything is all about here. So it's the process and the network itself is very old. It's confusing. The standardization process is kind of outdated. A lot of the structures and the ideas that exist have been around since the mid 1800s, and I read just a ton. And as a result of what I was discovering, I decided to create this little tool called this Standards Network Map, and I published that on a list apart. And so I'm still researching and writing about that today, because I just feel like I've just scratched the surface. But before we kind of go down that rabbit hole, let's talk about what a standard even is, because that was something that I was like, what are we saying here? So a standard is a technical specification that adopters can target as a representative implementation of a technology. It is not code, it's a document. And it describes what a piece of technology is, what it should do, and what people and companies who want to use that technology should be able to do. They should be able to read that document and implement it. It should be written in English and a form of like meta programming language that describes required algorithms for it to meet the standards. And another important thing to note is you're going to see a lot of documents that are described as technical specifications. All standards are technical specifications, but not all specifications are going to end up being standards. So that's a little fun fact. So why are standards important? Why do they matter? Well, they have a great deal of technical, social, political, and economic implications. You really need to have standards if you want to communicate effectively between systems. If you want to have interoperability within a single system like the web, you want standards. Standards impact how problems get solved and why they're solved that way. They help us kind of document the problem-solving process. They impact how we capture financial value. They impact how quickly new technologies are adopted, or whether they're even adopted at all. And they impact how we regulate technology. Lots of things get standardized, and not just in technology. We typically are thinking about standards for interfaces, data formats, vocabulary, languages, processes, frameworks. And again, there's a lot of ICT standards, but we have standards for business process and things like that as well. I used to work for, like back in college, I used to work for a printing company that printed ISO standard training books for auto mechanics. So you can pretty much guarantee that if it has anything to do with safety or business operations like that, anything like that, it's going to have some standards associated. So. Key components, what are some things that make a good standard? There are generally 3 things that I want to evaluate. One is its technical description, so what is it, who was it written for, IP rights, and the issuing authority. So let's take a deeper look at those. So technical description, how easily can this be read? Can it be read by human beings? And what other specifications does it cite? A lot of times you will look at a spec and it will actually have requirements of conformance to other specs. What makes this, sometimes the spec reading process very difficult and challenging to me is that it's often written in a meta language, like I was saying, and that can vary from specification to specification depending on the editor, depending on the issuing authority. There are also some pretty important keywords like that were defined in the IETF RFC 2119, like must and shall and normative and things like that. But those keywords, they don't always mean exactly the same thing across specs, so that's also confusing. So again, if it can be well read, easily read by a human being, it's a great spec. I think the ECMAScript spec is a really easy to read one for most folks. It's got a lot of notations and things about definitions, and it's pretty well honed at this point. The W3C is actually undergoing had last fall study, how can we improve the readability of W3C specs, and they were partnering with the university on that. So I'm not quite sure if the results of that are done, but that's a great thing that's going on. All right, IP, yay. So because a specification is not a piece of software, it's a description of a piece of software, it doesn't really get a license the way software does. It doesn't get like the MIT license. It gets there's patent assignments. So before anybody can safely implement a specification, it needs to have a policy that can be cleared by your legal counsels. So this means that the people who've created the specification are going to make it clear what, if any, rights are going to be retained, and any terms that for patents that might be infringed as a result of implementing the standard. So in web standards, the most common types of IPR policy that we see are royalty-free and reasonable and non-discriminatory. With the RF policy, you can access a description for no charge, you can share for no charge, you can implement it for no charge, it's royalty-free. And generally it also means that you can be released of any patent infringement claims from member organizations who participated in creating the spec but may have snuck in like a submarine patent or something. The RAND policy puts terms around that. You might have to pay an implementation fee, but again, it's that reasonable and non-discriminatory, so they can't kind of do anything too outrageous. You might have to pay for a copy. You might be able to implement some parts of a specification, but not all of it. So, yeah. Issuing authority. Other component of the specification is who is publishing it. So is there a standards body, an industry consortia, or a group that's been working on it collectively? Or is this a specification the product of a single organization and their efforts? Are the specification's creators willing to and able to shepherd the specification and make changes to it? So is there a change process associated with that? Do they plan on evolving it over time? Will it be supported over time? Or sometimes companies look for a place that they can specify a thing and then kind of like dump it. So there are hundreds and hundreds of standards bodies. They all organize their work slightly differently, but almost all of them rely on the smaller working group method to kind of bubble up the work to the top of the org. So let's take a look at Ecma, because that's the one that standardizes JavaScript. Or ECMAScript. So I made you a starter pack because that's my favorite Reddit. Ecma was formed in 1961, and it was formed as a response to some competition from American computer companies, and British and the EU. A lot of those industry groups were like, we need a body to kind of work together collaboratively on standards that will compete with American computer manufacturers. So mostly telecom companies that joined, and over the years, that's what they've been focused on. In Ecma, we have a bunch of TCs that do their technical work that reports into the Secretariat. The General Assembly is a just group of member companies. They send a delegate, and the General Assembly is responsible for making any votes on policy changes and so on and so on. There's a management team, like a president and a treasurer and a reporter. They do kind of like the board type duties. And then there's an executive committee, which is more engaged with, it's a subset of the General Assembly who makes other kind of recommendations to the GA. So we really view the TCs as kind of being like in charge along with the GA. It's a really small standards development organization. It runs pretty lean, and I like that. I think that's a good thing. JavaScript is extremely important to Ecma, and you know, so I think we're very happy and doing a lot of good work with that group. Questions people ask about Ecma often are how do you join? It's a really easy process. You just email the Secretariat and they send you a form, and the fees are pretty cheap as well compared to a lot of other standards bodies. So we have 12 active technical committees right now, about 34 active members. It's a good place to go visit. So let's talk about types of standards, because an issuing authority can have multiple types of standards that they standardize. The first is probably one you're very familiar with, proprietary standards. Those are specifications that may or may not be published by a single organization, and that organization is going to retain usually all rights to the standards, you know, to license and so on and so forth. This is kind of like the bad kind. Another kind of standard are de facto standards. So we also call these community standards because the thing is, this is a bit more like the populist standard. A de facto standard can be a proprietary standard that has gained so much market share as to be the default. And that's kind of the word, de facto, the default. So you can get a proprietary standard that's gotten so popular that everybody's like just using that by default, even though it's not open. So like the Office document format's there for a while. It can also be a community specification that has gained so much popularity without necessarily having gone through the governance process of a formal organization, like Node, for example. And at that point, you might say it's a community standard. So they gain prominence through widespread use. That's the key thing to remember. The problem with de facto standards is that they're often controlled by a single vendor. And that means they can and often do change it whenever they want based on maybe their product direction or something like that, or if a product needs to go from one major version to another. So you know, that's the risk of a de facto standard. We have de jure standards. So these are standards that have been put through a formal process for adoption and endorsement by some official standards setting organization like Ecma, or we also have government standards bodies like ANSI, you know, ISO, and that sort of thing. So the word de jure means from law, so that's a good way to remember that. And de jure standards are typically legally protected or enforced in some way, shape, or form. And the IP rights that are retained by a de jure standard can vary from organization to organization. Then, lastly, we have voluntary consensus standards. So this just means that the technical specification for the product or process has been developed in a fashion that is consensus-driven or consensus-seeking. That's really all it means. So, you know, that's just good to know. So none of those words are open. What in the world makes a standard open? Well, this gentleman named Ken Kretschmer conducted a really lengthy study on how do we define an open standard, and he came up with like 10 metrics, because of course he did, that you could classify a standard as open or not. So first, obviously, is openness of participation. So can all stakeholders participate in the standardization process? You have a consensus agreement. So how is that decision-making process? Is it all interests are being discussed and agreement found with no domination, or is there some kind of voting system? Due process, is there a balloting or an appeals process if there's a conflict and we need to find resolution? Is it the same standard all over the world, or is it for the same function, or are there regional standards? This happens a lot in Asia. Open IPR, so you can have low or no charge for the IPR necessary to implement a standard. Open access to documents, so can you, if you're interested, can you access the committee documents, drafts, completed standards, deprecated standards maybe, that kind of thing. IETF does a great job of making all their documents open. Let's see. Change process, so do you have a change process that people can propose and agree upon during the standards process? Interfaces to support like migration and backwards compatibility and that kind of thing. Access, are there objective conformance mechanisms as well, and ongoing support. So can the standards be supported until the interest ceases? So lots of different factors to making a determination about whether a standard is open or not. So all of this indicates that openness in standards is not a binary. It's a scale. That's how you have to look at it. And as technology matures, the specifications may change from one category of standard or one, take a step from one side of the openness spectrum to another. You may have alternate versions of a spec that fit different categories. And they're not necessarily mutually exclusive either. So you can have standards that end up being sometimes both closed and de facto and so on and so forth. All of these kinds are represented in web standards, but typically we see de facto and voluntary consensus standards as the most abundant. So where does JavaScript fit in? How open is JavaScript? So we have for Ecma an organizational membership structure that is very easy to join, but it is a paid structure, so there's that. We don't have individual memberships. You can join a technical committee as an invited guest, so it's open. There's a way to get in. We do our technical committee at TC39. Our decision making is consensus seeking, but if something has to go to the General Assembly for whatever reason, they do a vote. We've never had anything have to go to the General Assembly for a vote other than, yes, we approve the standard, and they have always approved the standard. We have done a lot of work to improve our tooling so that by, like, for example, moving the specification development to work to GitHub so people can participate in the process, watch what's happening, see kind of how decisions are progressing and that kind of thing. And another cool thing that we're trying to work on is kind of popping up little community interest groups like around education and that sort of thing. So we can get people to feedback on that. JavaScript itself is obviously a worldwide standard. We have royalty-free IP on policy for JS. It's free for everyone to view or download. You can also, Ecma will mail you a copy of JavaScript if you want. That's a thing that they will do. They'll print it out and mail it to you. And then we have a test suite that you can contribute to. So we've got that conformance test suite. So you can, if you're building an implementation, you can ensure that it meets the standard. And then lastly, we have a lot of improvements to our process that we're working on. As I mentioned, the groups, we're trying to make sure that a lot of the archival documents about the early days of JavaScript are getting kind of put in an accessible place somehow. Yeah, so, and then, yeah, improvements to process, so on. So let's talk about a quick look at JavaScript's history, which that's going to be a little hard to see, but a thing to remember here is that JavaScript is a millennial. It's 25 years old. And one thing that happened was it was kind of born out of a competitive move from Netscape kind of to stave off Microsoft. That's why they submitted it as a standard to Ecma. Fun fact, they actually tried to take it to the W3C first, but the W3C thought that it didn't really fit with what they were doing, so they passed on that. And they then went to the IETF, and they thought, maybe we should do this at the IETF. And then they thought, no, that's going to be too slow. So instead they went to Ecma, because Ecma was like, yeah, whatever. So that's why it's standardized at Ecma. So it's submitted in '96, and then in less than a year, they had the first edition published. That's lightning fast. That's super lightning fast. That standards don't usually work that fast. Then they had the next edition published a year later in '98, and then another edition in '99, and then no work for a decade, the lost decade of JavaScript, which some of you probably remember with horror. So why did that happen? We didn't really have those processes, those open processes that I was talking about earlier, really in place. The process failed, and so that really led to a big breakdown. Now, during that period of time, we got to see a lot of great open source projects bubble up and you know, kind of provide solutions that the standard should have been providing for us. And I think people on the committee, especially, Brendan Knight came back to the committee. A lot of people started coming to the committee from jQuery and other groups, started talking about things in a more collaborative fashion, started opening up the process, and then eventually we did get it restarted. And so that's kind of, that's crazy to me. So what does the new process look like after that? We have a proposal process. You can check it out. There's a GitHub repo for this, and there's a process document at the github.io URL right there. But there's essentially a 5-stage process where, you know, stage 0 is, I have an idea. This is just some spaghetti I want to throw at the wall. Do we find this interesting? And if the answer to that is generally yes, there's some interest, then it might go to stage 1, where it becomes a formal proposal, and this is something that you might author, maybe, I'm just saying, and submit. It's, the purpose here is we're gonna talk about high-level, you know, implications, we're gonna discuss challenges, that kind of thing. And then once that feels like it's taken some good shape, the committee would then maybe move it to draft stage. At this point, it's got to start looking like a spec, so it gets its draft spec language, more precise syntax, that kind of thing. You might start thinking about how you're going to test it. You might have some implementers who are like, yeah, you know, I'll see, you know, about testing this in an implementation, that kind of thing. The best place for us as community people to get involved is really between stages 2 and 3 here, because between draft and candidate, that's where you're going to see a lot of different debate pop up, or proposal and draft, I'm sorry, you're going to see a lot of debate pop up and people kind of thinking about different solutions for a problem. At stage 4, we are saying it's a candidate. Candidate stage is stage 3, sorry, because it's 0 indexed. We're looking for refinement, feedback, and then we also are looking for tests at that point. And the final stage is, hey, you know, this is done. The criteria has been met. All of our tests are in. The editing team, which is Bradley Meck, Jordan Harband, and Brian Turleson, who are amazing individuals, they've signed off on it, that it's met all the requirements. And at that point, it's in, it's done. It's going to be in the next edition. So again, this is where you can go follow along with specific proposals that you might be excited about, and look for opportunities to weigh in with use cases from your organization, or maybe volunteer to write tests. That's a great thing if you're interested in doing that. So once that proposal is finished, then we're basically waiting on, you know, the yearly publication process to complete before it's in the final PDF, you know, of the spec. So anything that was stage 4 is in. We have 6 in-person meetings a year, so those happen about every 2 months, and that's where we're going to have a lot of like conversations about like you know, disagreements, or like kind of ironing out details, that kind of thing. People will take turns presenting their proposal. We'll have a discussion about it and kind of go from there. At the November meeting, we have a feature freeze. So everything that made it to stage 4 prior to that meeting is going to be in the spec, and we're not going to really work on trying to get any new features in until the next year. Then we have a text polish period. This is where the editors are going to take time to refine the language. They may start adding like informational notes that just make the text a little bit easier to read, that kind of thing. So that happens between November and January. Then in January we have this 90-day spec text freeze, and that is to do IPR clearance. So it gets sent off to Ecma's the Secretariat, and they go make sure that if anybody has anything that they need to say about it from a patent perspective, nobody ever really has, that they get that opportunity to do that. And so then in June, the spec gets sent to the General Assembly, and it is approved by vote in June. The Ecma International will officially publish that spec as the latest edition, and that's essentially the yearly publication process that we're on now. So the current edition is ECMAScript 2018, ES 2018, also known as ES 9, but we're trying to use the years now, and I know that's really confusing. So hopefully this insight into the TC39 process will illustrate for you that we're kind of moving toward this standards meets open source process of working. And I think that's really, really exciting. I think we have to do that. Because for one, as I said, a lot of the standards bodies and Ecma as well is kind of building on a process that started in like the 1800s, and they've kind of continued that way of working. That doesn't really work for software. It doesn't really work the way that we work. So that's been a good run, but it's time for those methods to evolve. And I think TC39 in particular has been a really high-functioning example of how they can do that in a way that captures the benefits of the standards process, but also the innovation and the involvement and the openness of open source. So I think that's pretty cool. So I think I'll leave you with this last little note. I'm hoping that you will agree with me at this point that how we create technology is just as important as the technologies that we're creating themselves. If we're able to keep this up, to work together, then I think we'll do a better job understanding what we're doing both in theory, which is the standards world, and in practice, which is the open source world. I think we'll be able to better analyze and critique what we're doing or what we've done in the past and learn from it. I think we'll be able to produce more successful technologies and hopefully also more successfully adopted technologies. And kind of identify what that line is between our theoretical and philosophical foundations, while also checking in with whether what we're doing in practice meets all that. In my opinion, if we don't really work on that, if we don't really work on following that thread, we're going to lose a shot at really understanding true computer literacy. So thank you so much for listening to me ramble about standards. I'm at jory.com on Twitter if you want to continue the conversation. Unfortunately, I have to leave a little early today. But